Our next presenter is actually a very close friend of mine, and when you go to the clinic, you might see why. I can tell you this, when you have a friend on the other side of the planet, you can write some code a little quicker, because when I'm asleep, he's writing, and when he's asleep, I could be writing. So our next presenter is from Melbourne in the Australian state of Victoria, and he models the trains of that state. Having worked in IT since before it was called IT, he has an affinity with digital technology and applying newer technologies such as 3D printing and microprocessor technologies. To tell us a little bit about some new kid on the block called MQTT, we welcome David McMorran.
Thank you, Speed, and g'day everybody from Melbourne, Australia. It's a lovely sunny Sunday morning here. A little bit on the cool side, but I've had my Vegemite and toast for brekkie, so I'm ready to go. So let's dive into it.
Cool.
Okay, MQTT, that's what I'm talking about. What is this, you're probably wondering? It's a simple way of using inexpensive devices to control accessories on your layout. Now, I'm talking about your turnouts, your signals, detecting sensors, that sort of thing, or lights on your layout. One of the advantages is that it's very little wiring needed because we use Wi-Fi. And as an added bonus, you don't need DCC, so this will work on any layout. So you can even use it on the DC layout. Today I'm going to talk a little bit about what is MQTT, how we can use it in model railways. I'm going to go through quickly the setup in JMRI, the sort of microprocessors that we might be using, how to set those up, and a little bit more about where MQTT is being used and where it might be going. But right now, let's see some action. Okay, now this might be a familiar layout to some. It's not mine. Thank you, Speed, for doing some videos of your layout. So we'll see some of this action. There's a fair bit going on there. Trains are coming in from both ends. We can see a train coming in the distance. And there's two separate screen diagrams on the left-hand side. I'll explain those a little bit more in a moment. I'm just going to hold it there for a moment. In the bottom right-hand corner, you see there's the tables from JMRI. There's a sensor table and a turnout table. The names might look a bit strange to people, but that's the MQTT names. In the bottom left-hand corner, there's all these messages getting posted. So they're all the messages from MQTT. They're the messages that are driving all this. I'll let this roll a bit more. You can see that we've got trains coming from both ends. There's turnouts here at the crossing that's just flipped over, you might have noticed. And trains come the other way. Now, what you might be noticing in the left-hand corner there down the bottom, there's messages come up. You can see there's some that talk about sensors, some that talk about servos. So the servos are the turnouts, so the turnouts have been flipped. And every time a sensor detects occupancy or it changes from active to inactive, there's messages get posted there. And the track is clear, the points get changed again. And then as the trains move out, you'll see lots of detectors indicating active and inactive as the trains move along. Now, I'll just fast forward a little bit and we'll have a look underneath, see what's going on underneath. Same tables at the bottom, but now you can see the lights flashing on the sensors that are underneath the layout. So every time one of those lights goes on or off, then there'll be a message posted to MQTT. Okay. Okay, now what is MQT? What does it stand for? Right? It stands for Message Queuing Telemetry Transport. Right, that's a bit of a mouthful. Telemetry is an interesting word because that means remote measuring, which gives you a clue about where it's come from. It's from monitoring oil pipelines through the desert using battery power. So there's no big computers involved. So what does that mean to us? It just means it's a lightweight protocol for sending messages. Simple as that. And even better, the software is free. Okay, so how does this all work? The messages are a publish and subscribe technology. You have the server where the messages get stored, and you have a number of clients that are connecting to it. So you can think of it a bit like a mail server. You have your clients. It could be your phone or your computer or your tablet. You connect to maybe Gmail that's on the server, and you see if you've got any messages and you read your messages. So this is the same sort of thing. Is the clients will publish the message to the server, and the clients can be subscribing, which is waiting to see if there's a message for it to do something. The messages are usually sent over Wi-Fi, so that makes it easier without wires. It's really an Ethernet protocol, so you can have Ethernet if you want. So let's have a little bit more of a look at the messages. The message has two components. It has a topic and it has a payload. The topics describe the object that you want to control, and the payload is what you're going to do with it. So it's a repository. It's a tree-like structure, a bit like your files on your computer. You have a directory tree, and then you have the document at the end for the individual one. So there's a couple of examples there. The one that you saw in the video was down the bottom, where there's a topic for the sensor and an active state. So that's the messages. Just one word, a little bit about retention. Normally, when messages are posted to MQT, you mark them to be retained. So what that means is that the last message for any given topic is retained in the broker, as I call it. That message will stay there until it's superseded by another message for the same topic. Now, one of the advantages of that is if JMRI shuts down, or if the microprocessor shuts down, when it starts up again, it sees that message, so it knows what the state is supposed to be. So at the start of the day, is often a problem with unknown status of things. Once they connect to the broker, they get told what the status should be. So they get straight back into business. Okay, now a little bit about putting it all together. You need a Wi-Fi network. We send messages over Wi-Fi. It is the easiest. Yes, it can be wired Ethernet, but Wi-Fi is easy. You need an MQTT server. This can be the computer that you're running JMRI on, or it can be a Raspberry Pi Zero, if you want a small one, or any other computer that you have handy that you'd like to use. There are a number of MQTT products around, but the common one that we use is Mosquito. That's not a typo, it is a double T. And that's free software, so that's easy for us. So that's all there is for the broker, the server. Now we'll have a look at JMRI. This is using the latest test version, 4.21.1. There have been a couple of significant extensions added to MQTT in that version. It now has support for sensors and lights, and the names of the topics that MQTT uses is a lot more flexible. So in the middle there is basically the default values. That if you start up a connection in MQTT, that's what will appear. The one highlighted with the green circle, that's the only one you really need to be focused on, is the address of where you've installed your MQTT server process. If that's the same computer, then you could just put localhost there. So the rest of it you can just leave as they are. I don't like having /trains at the start of, so I always change that one. In the right-hand side there is the settings that would work for speed with the messages that we saw in his video. So you can see now you can have pretty much anything or even nothing for some of those components. The purple section, the purple highlight, are the parts of this. Those get used to make the topic in MQTT. So those two will be combined, and we add to that when you create a device, whether it's a turnout or a sensor. In this case, it's a sensor. So the hardware address that is used there becomes part of the topic. So those three components get put together to make the topic that MQTT will use. And then it just sends the state in that table. So it'll be sending active or inactive. Okay, now a little bit about the microprocessors. We're looking at fairly cheap devices. The ESP01 on the left-hand side, that's about the size of your thumbnail. So it's pretty small, quite powerful for what it is, and it's only about $2. Node MCUs can be used. I have a few of those that I use, or you can use Unos. It's anything that basically has a Wi-Fi, well, anything that has an Ethernet or a Wi-Fi. So they're commonly used. Now, some of the extra things that we add onto it, these are quite handy additions. So on the top left-hand corner there is what's it called, an MCP 23017. So that's a pin expander. So you can have an extra 16 I/O pins. If I go back to the previous one, this little guy on the left, he doesn't have very many pins, so you're quickly going to run out of pins. So with one of these boards, you've got 16 pins you can use, and you can add several of those. You can add up to 8 of those theoretically, so you can have quite a lot of pins. Down the bottom there is a PCA 9685. So they're used for PWM, commonly used for servo motors. You can have, I think that the maximum of those is about 64. So you could actually use 1,000 servo motors if you really wanted to get carried away. Now you still need something to get the job done. So these are devices that could be used. So servo motors is fairly common because they're inexpensive and they get the job done for throwing turnouts. The WS2812B RGB lights, yeah, so they're quite clever little things. They're little LEDs that have a smart chip inside them, so each one is addressable, and you can string them all together to means you can do it all with just a single wire from your processor. So 2 wires to complete the circuit, and so you can do all your lights from that. And then for occupancy detection, something like an NCE BD20. They're a bit of overkill really because they've got extra circuitry for controlling relays, but we're not using those. But they can be connected to one of those I/O pins. Okay, we talked about inexpensive. There's some prices. $2 for an ESP01. You can probably do cheaper prices than that, depends on where you go shopping, whatever your favourite store is, but you look around and see what you can get. So the second one there is the I/O expansion board with a header pins soldered into it. Unfortunately, they usually come separated, so you have to solder those in, but all the other ones are all pre-configured. To give you an idea of the size there, so they're all fairly small. I tend to use buck converters to drop down the voltage. So I have some of those, and they're 50 cents a pop, but you can get cheaper ones of that as well if you have fixed outputs. That one has an adjustable output. Okay, now this is a little peep underneath my layout. I have a Node MCU in this case with one of these PWM boards, and I have 5 servo motors connected to that. There's one there as an example. I have a micro switch connected to it so that it'll throw the polarity of my frogs for me. I've just recently done another one where I've used up 8 of them, 8 of the available ports on the board. So 8 turnouts from that. So that cost me about $20, $25 to do the motor and all the electrics to connect it to. Okay. Now a little bit about the code. This is standard Arduino code for MQTT. Basically, there's 4 important lines, 4 or 5 lines. You need to have the library to install. And there's the command there for starting up the object, to give it the address of your broker, the name of the routine you're going to call when there's a message that you've received, and the Wi-Fi details. Then you have the publish command, so you can see there's a topic with the payload, the status of the sensor, and true is the flag to say retain the message. So we normally use that. The subscribe message, so this is what the clients use it to watch for messages that are in that topic. So whenever there's a message change in there, then they know that they have to do something. And at the bottom is the routine that it calls. So then you can expand that to do whatever you want. Now this is what we've done. On the left-hand side there this is to configure one of those little devices that I was talking about, like an ESP01. We download the Arduino sketch into it, and then we configure it. So we save all this information inside the actual processor on its flash memory. So we need to, these have, they have access points built into them. You can start that up, the sketch will start that up to start with. So then you can call up this web server page. So this little guy is driving the access point. It's also driving the web server to provide the web page. And then you can enter into that the configuration details that you need to drive everything. So you're going to need, you can change the access point name and obviously the password. You want to put in your Wi-Fi system to connect to. You need the IP address for your MQTT server so that it's able to connect to that, and the details of the topic that you're going to be monitoring. On the other side is tables. So in this case, it's been set up for, as you can see in orange, that there's 2 of these modules that I talked about before, the I/O boards. You set their address, because they have individual addresses to distinguish between each one. And we configure each of those pins to be either as an input pin or an output pin. We can disable them if we want to. You can see there's a line for the state. So this is displaying the state of each of those pins. So this is a bit like climbing underneath your layout to see what the flashing lights are saying if you need to debug things, except that you don't have to climb under the layout to see it. Okay, now I'm going to come back to this one. Okay, I mentioned before that there's 2 different panels that was in the video there on the left-hand side. The one in the middle is a JMRI panel. On the top, the speeds used are just a web server page. So he's got Java code behind his web page to do the publish and subscribe to MQTT. So in that case, it doesn't actually need JMRI at all. It's just the devices talk to the broker, and you can have multiple devices, multiple clients looking at the same topic, and that topic will be seen by all of them. Okay, MQTT can be used by lots of other things. Yeah, the messages that we've seen in the examples that I've gone through, I've probably gone through that a little bit too quickly. The messages there have been quite simple, just saying whether the state of a turnout is thrown or closed, or a sensor is active or inactive, but the message can be more complicated than that. This MQTT really is just a messenger. It is just sending a message from one to another or one to many. It doesn't really care what's in that message. So it can be a complex string. So there has been some discussion about building LocoNet bridges or LCC bridges or even throttles connections, and all sorts of things. So there's a groups IO group mentioned there at the bottom that you can look at to find out some more details about discussions and ideas that people are discussing there. And also, you're not limited to just your local network. You can connect to the cloud and connect to MQTT servers out there, and yeah, so your dispatcher, if you want to have in some remote location, can be using this technology to see what's happening. So there's lots of ideas that you can use there. There's lots of flexibility in that. But for my purposes, at least, I'm just looking at it mainly to drive my turnouts and for sensors and signals. This is a little application that I like to use. It's not part of JMRI. It's not part of MQTT. It is just an extra application. It's another client that connects to the server, and it's just for showing the messages that are inside the server. It's just handy when you're trying to see what's going on. You can actually publish messages through this. So it's just a handy app to have when you want to see what's happening in the broker. You can find that online, MQTT Explorer. Yeah, MQTT has moved on a little bit from where it started in the desert. If you Google it, you'll find lots of examples of home automation. I turn on the bedroom light, the upstairs hallway, turn the light off, turn the kitchen light on, all those sorts of things. So MQTT might not be in all of them, but some of them do have the capability to use MQTT. So that's where it's often used these days. A little bit about what is coming ahead. Signals is what I'm keen to see. It's not in JMRI yet, but it's coming. But in the MQTT world, there's signals there that do work, and if you have a look behind Speed's at the bottom of the helix, have a look behind his left shoulder, you'll see some lights flashing, and there's signal masks that are driven by MQTT. But not yet fully available in JMRI. So what else is coming? Two things that use similar technology, home automation and model railroads. So you bring the two together so you can have JMRI switch on the kettle for you. Just tell it to switch on the kettle so when it's time for coffee, or at the end of the day, you might have, when JMRI shuts down, it will also tell your power controls to switch off all the IOUT power, turn the lights out, turn the heater off when it's time for bed. Okay, all right, that's been done already. People actually do that. So the next step is, well, talk to your layout. That technology obviously is there now. It's just a matter of somebody putting the pieces together. So now you can talk to your layout. And I guess the question is do you really want to? Because sometimes those things have big ears and they might hear things that they're not supposed to, and they might do things that you're not really wanting it to do. But that's something that you can deal with. Okay, running way ahead of where I thought I would be. I've gone through this a little bit too fast. The bottom line is using Wi-Fi that reduces the number of wires that you have to use. I run a 12-volt DC bus around my layout, so I'm using the fairly inexpensive buck converters to drop that down to either 3.3 volts or 5 volts, depending on what you need. The servo motors run off 5 volts. The ESP01 is a 3.3 volt device. You can get them from your favorite shopping place, Amazon, eBay, or various other places. I tend to use AliExpress a fair bit, whatever is your favorite. And the code for the sketches, the plan is that the MQ Trains code that we're using will be open source by Thanksgiving. All I'm waiting for is signal masks to go into JMRI, and then I'll be happy. I've probably rushed through that. Well, I have rushed through that way too much. So there might be a few more questions about there. I might need to go back and re-explain some of that. So I guess Speed, if you've got anything to add here.
Well, let's go through some of the questions. First question, how did you get involved in MQTT?
How did I get involved in MQTT? Well, I was looking at a few other technologies because I was looking at using Arduinos to try and control my turnouts and what have you. And I was looking at serial buses. That was getting a bit complicated. One of the notice boards, one of the forums, I saw that somebody was giving a few details about serial buses. Like, this guy seems to know a bit, so I thought I'll chase up with him for a bit more information. And that's how I stumbled across speed. And he introduced me to MQTT as an idea because he'd been using that, and I saw that and I thought, well, that's a lot simpler than the serial bus stuff that I was trying to sort out. So I've been going with that ever since. Just a lot easier.
Okay, next question. Can MQTT do what LCC does?
LCC and DCC is really about, well, yeah, they're bus technologies. MQTT is just sending a message. It's a fairly open, as you can see, they're just plain text messages, so they're not really complex things. It's a publish and subscribe message, so anything that gets posted to a subject is open for any number of subscribers that might want to see it. So it's not just a one-to-one thing. They're different. They can do, there's an overlap in what they can do. But I guess the MQTT, it's because there's not much in it. It's just a simple message. Then you're not tied down with lots of standards and complicated message structures and stuff like that. You can be, if you want to get into really fancy stuff with some of those complex messages that I was talking about. So in that case, it can be quite a complex message. It's just, MQT is just a messenger, right? So it's one device sending to another device. As long as they understand the content of that message, it can be simple or it can be complex. It doesn't really matter. To MQTT, it doesn't care. It's just passing that message along. So to control your turnouts, it's just a very simple message to throw this turnout. And you don't have to know any complex protocols like LCC. I haven't dived into that one in great detail. It just sounds too complicated to me for what I need.
So is there an advantage that MQTT has over LCC?
Well, one advantage that springs to mind, if you don't mind a little bit of do-it-yourself stuff, is the prices. We're using a $2 processor board with another few dollars for a few extra add-ons. So for $20, oh yeah, but then you can put similar sorts of scripts into those to talk to LCC, I suppose, as well. It's just MQT is simple. The simple messages, so that's the attraction for it.
Okay, where can we go to learn more about this and how to integrate this into our layouts?
Okay. If you rewind the video, you can have a look underneath the speeds layout, and you can see where there's I/O pins. Sorry, where there's the coil detectors for circuit detection. If you look below that, there's it's obviously a temporary setup, but there's a breadboard there, and there's a little ESP01 sitting next to that just plugged into a USB connection. That's just a temporary setup. But the idea is that you can have several of these spread around your layout. wherever it's strategic for you to do so. And they all talk Wi-Fi, so you don't have to run wires to all of them other than just the simple power. So you don't have to run lots of wires back to a command station. So you would put one of these probably typically wherever there's a busy part of your layout. So where you've got an industry or a couple of industries where you've got lots of turnouts and sensors, signals, then you could have one or two of these to service that. Probably one is enough to control all those devices. So all you got to do is, I showed you the picture of how I connect my servo motors to that board, and that just sits underneath the layout. I had 5 or 8 turnouts in that particular area, so there's one device that I would use to control all those. Then you don't have to run wires, as I said, other than power. So it's just Wi-Fi connection to the broker, and JMRI then sees all those messages. So the sensors and the turnouts, once you've created the MQTT turnouts, whatever objects, they can be used in JMRI just like any other turnout, whether it be a LocoNet turnout, NCE turnout, whatever. So you can use them in all your automation, operations sort of stuff as well.
Okay, so someone wants to know what make are those black sensors underneath? Tongue in the cheek, I'm going to let you answer it.
Yeah, okay, all right. Yeah, in the notes I showed examples of an NCE BD20. I have connected a couple of those to try out so that they connect to those little I/O boards. So it triggers a sensor, so JMRI then sees that message. All right. So those black coil things that you saw under Speed's layout, they're similar to that. If you Google a little bit, you can find there's a few circuits there that people have published that do similar sorts of things. So you can put together a circuit yourself if you want. But basically, you have a coil there that's detecting the current of the AC current, or effectively AC current from DCC. So it triggers the occupancy detection. So those little black coils are similar to the BD20s.
Now you answer the next question, if they're current sensing or infrared.
Yeah, well, you can use this for anything. If you use a BD20, then that would be current detection. If I wanted to have an infrared detector, LEDs transmitter detector, you can connect that to one of those I/O pins, so it will trigger as well. If you have a light sensitive resistor, that sort of thing, where it detects the shadow when the train rolls over the top of it, that I will be putting some of those in my layout, particularly at my station where I want the train to stop at the right place. So they will just connect to one of those I/O pins, and it will trigger as active when the train covers it. So any of those sorts of things. So you can use diode style currency detectors as well. They will just activate send an active signal to the sensor.
So another big question is, what is this MQT range code he's referring to?
Can you say that one again, please?
What is the MQ trains code that
Oh,
you
MQ
refer
train.
to?
That's the name we've given to the sketch that we've put onto these little devices. So when we make that public, then it'll be easy to download that. Then you can just download, use the Arduino IDE to load that sketch into your little device. And then when you start it up, it'll start up its own access point, so then you can connect to that with your phone or whatever browser that you want, and key in all the rest of your configuration details that you might need. Set up which pins you want for I/O. So that's what MQTrains is. It's just that's the name of that sketch that we're using, and we'll be making that available.
Do you mind showing the slide with the Arduino code on it? Because Andy wants to know what the XXX is referred to.
Okay. Okay, all right. So this is just trying to show the MQTT specific lines of code. The MQTrains sketch, as you saw from what it's doing a whole lot more. So looking at the second statement there, the MQTT client statement. So that's where it's establishing the connection to the MQTT server. And in the blue text this is the name of the section of code that is going to run when a message is being detected that it needs to process. So going down to the bottom, you have this void loop. So that's void statement is basically the syntax of this is what you put in your code. So the actual loop itself now is up to you to write whatever code you want, or you can use the full code that we have. So XXX is just, that's not meaning anything there. That's a block of code that you have to write yourself to decide what you want to do with the message.
So if the payload...
So just to highlight, these are the MQTT specific statements.
Correct. So when the payload shows up and it matches what you think it should for that topic that was supplied, then you do, in this case, output 14 high.
Yeah, so that's so you write the code to do that. So when that message, that's that topic, that you get the payload and okay, you want to set that high. Yep. Okay.
Okay, let's see if there's someone else asked, are there less expensive current sensing block detection options that you know of?
Yeah, that's something that I've been exploring a little bit. You can find coils. If you Google, you can find coils that are that you can buy that are cheaper. I can't give you a price exactly on those because they vary a fair bit, and I haven't bought them yet, but I've been getting close to it. Then you'll have to get the extra components for the extra little bit of circuitry that will be involved. So I'm looking for a bit more guidance from the master on how I'm going to put that together. There's a hint speed. And so, yes, you can do it a little bit cheaper. The BD20 is quite a nice unit. It's one of the downfalls, I suppose, if you call it a downfall, but is that it's got extra things in it. We don't need to drive relays, so it's got extra circuitry in it. So that makes it a bit more expensive for something that you don't need. So yeah, there are cheaper alternatives. I can't give you a price on what that will be. And it's a bit more DIY.
I just want to note that there are some very inexpensive current sensing boards that you can find on AliExpress or some of the other places. What you need to watch out for is that you can measure the DCC frequency as well. The 50 hertz sensor will not measure DCC current.
Yeah, so you have to be careful which ones you get, and there's a little bit of extra circuitry as well to make it work. So in Google, you can find examples of that extra circuitry, and it depends a bit also on the number of loops inside the device. So they have different numbers of turns inside it, so that affects the sensitivity of them. So you just have to be careful which ones you get. I can't tell you at the moment which one.
Okay, last question. And since you know how much I love to do this, you can tell the people. Has Speed also done videos on articles on his MQTT use on his layout?
You'll have to fire that one past me again.
Has Speed also done videos or articles on MQTT on his layout?
Well, that's probably a question you'll have to ask Speed. He's done this. He probably hasn't, because he was too busy doing this video for me.
What an impossible task to control 2 trains. Probably took 15 runs to just get those 2 minutes that Dave was showing. So I told Dave and Joel, who's another guy helping us, but I will probably never ever do this again.
So there's your answer. No, he hasn't done any. He's done one for me, and he regrets it.
Dave, thank you very, very much. That was simply done marvelous. Next time, I think we should see part of your layout, don't you think?
Well, we'll work on that. I'm still working on that too, so that's a little way off yet.
Definitely if it's Victorian Railways.
Yeah, look, I spent the best part of a decade where I was working. I was looking out over the steel yard in Footscray Road. So in between doing a little bit of work, I was watching the trains. So I like to model the trains I used to see out my window.
Exactly.